Hello chemistry students, here is homework corrections for page 62, 14, and 16. Question number 14 says, determine the number of significant figures in each of the following measurements and calculation results. So letter A, 12 basketball players. Well, how would you figure out there were 12 basketball players? You would count them. So because you count, this has unlimited significant figures. In the second one, 0.010, this one is significant because it's not a zero. Rule number one. This 0 is significant because it's to the right and at the end of a measurement. So this has two significant figures. Letter C, 507 thumbtacks. Again, this is unlimited because you would count them to figure out there were 507 thumbtacks. In letter D, the 7 and the 2 are significant because of rule number 1, they're not zeros. The zeros between the 7 and the 2 are significant because of rule number 2. And this 0 to the right of the decimal and at the end of the measurement is significant as well. So that gives us 5 significant figures. Letter E, the 1 and the 8 are significant because they're not zeros. The 0 between the 1 and the 8 is significant because it's between numbers that aren't 0. These last two zeros are just placeholders. This is that understood decimal where nothing is written. So this has 3 significant figures. And letter F, the 5 is significant because it's not a 0. And these two zeros are significant because they're to the right and at the end of the measurement. So this has 3 significant figures. Number 16. A technician experimentally determined the boiling point of octane to be 124.1 degrees Celsius. The actual boiling point of octane is 125.7 degrees Celsius. Calculate the error and percent error. Okay. So experimental value was 124.1 degrees Celsius, accepted was 125.7. The equation for error is the first thing you have to show, which is accepted value minus experimental value, and it's the absolute value of that. So when I plug that in, my accepted value is 125.7 degrees Celsius. I'm going to subtract 124.1 degrees Celsius. Now, again, I do need to pay attention to significant figures and such, and we're adding and subtracting, so it's position, and each number has 1 decimal point, so my answer has to have 1 decimal point. So I do this, and I get 1.6 degrees Celsius. And this is right in terms of significant figures because when I add and subtract its position, my last significant digit is in the tenths and my last significant digit is in the tenths. Now to calculate percent error, it's the absolute value of the accepted minus the experimental divided by the accepted times 100. That's my equation. So I plug in again my numbers, which would be the 125.7 minus the 124.1 divided by my 125.7 and times 100. And again, in terms of significant figures, 1.6 has 2, this has 4, so my answer should only have 2, so it should be 1.3% error. Have a good day. Talk to you tomorrow.